Assalamu alaikum and good day to everyone at the second ICAT 2022. My name is Samin Enam and I'll be presenting my project Numerical Investigation on the Effect of Grille Blockage Ratio on Airflow Characteristics of Air Vents. My co-authors are Mohammad Noor Afiq Witri Mohammad Yazid and Noor Azwadi Che Siddiq. My content includes introduction, methodology, results and discussion, and conclusion. Firstly, I'd like to discuss what is air ducts. We are all aware of air ducts. They are conduits and passages commonly used in ventilations, HVAC, heating to transport air. What are louvers? Louvers are a system of horizontal or vertical slats that are angled to admit air. They play a huge role in ensuring airflow around enclosed spaces. What are the roles of louvers? They play a huge role in design flexibility, they allow the passenger to control airflow, and they play a huge role in ensuring quality indoor air. Now, what is the importance of this study? A huge amount of research has gone into identifying and understanding how aspect ratios and louver angles play a huge role in ensuring quality air. But blockage ratio goes largely undiscussed in this space. Why is that? Because blockage ratios are usually the second-hand player, or they are taken as the non-important guiding force. But as more and more research unveils, we understand that blockage ratio is vital to ensuring quality indoor air. And that is what our study tends to do. Our study tends to provide a theoretical basis for designing automotive air vents. What are the research objectives? The objectives are to conduct validation study for rectangular duct, to analyze airflow characteristics of air vents, and to ensure or investigate airflow characteristics issuing due to varying blockage ratio. What we can see from all the literature is that CFD allows for determination of the behavior of entire flow fields and can easily analyze conditions that are difficult to measure in experiments. Therefore, we intend to do a numerical analysis to investigate airflow characteristics, which are but are not limited to pressure drop, internal flow characteristics, flow phenomena, and etc. It is expected that the present study can provide a theoretical basis for improving aerodynamics of air vents in automotive vehicles. Discuss the research methodology. Firstly, the validation study, which was based on Fajhani et al., can be seen here. We took the inlet, outlet, symmetry, and the walls. The walls were taken as no-slip conditions, and the symmetry were taken surrounding the inlet. Here you can also see the validation model and the mesh. Next, we'll briefly discuss about Salome. Salome is an open source software that is used to create the geometry models, and it was used for meshing. Now you can see the domain setup here. You can see the inlet, symmetry, and the outlet. You can also see the different vents that were taken into consideration for this study. The 4 louver vent, the 5 louver vent, and the 6 louver vent. You can also see the mesh of the computational domain and a close-up of the louvers. Next, I'll briefly discuss the K-epsilon turbulence model and the boundary condition parameters. The K-epsilon turbulence model was chosen as the turbulence model for this study because, according to Burch et al. 2006, the K-epsilon turbulence model was the best in predicting streamwise velocity decay along the jet center line in both the near field and the far field regions. All these were in good agreement with the experimental data. Next, you can see the tabulated boundary condition parameters for air. With the software that was chosen to carry out as the solver of this project was CodeSaturn, because CodeSaturn is a free, open source, and a very user-friendly software to carry out CFD simulations. The volumetric flow rates that were chosen are 0.027, 0.041, 0.056, and 0.080 meter cube per second. TaraView is also another open source multi-platform data analysis and visualization application that was chosen as a cross-processing software for this study. Now, what are the investigations that we're trying to do? We are trying to find the pressure drop, the centerline velocity decay, the streamline velocity, and analyze the jet development due to blockage ratio. Here are some things that must be considered and taken into consideration when you are judging the study. This study was taken as a steady state condition, thus all transient conditions were excluded. The temperature was taken as constant, thus the study was taken under isothermal boundary conditions. The flow rates are not universal and they are not applicable to all flow rates. It is taken within a range. And the car or the cabin volume was neglected. Next, I'll discuss the results. Firstly, I'd like to discuss the results for convergence. Here you can see tabulated the three coordinates that were taken into consideration for the convergence study. You can see that for the point that is closest to the inlet or point 1, the study converges within 200 iterations. But as the point moves further away from the inlet, the number of iterations increases significantly. In the next slides, I will also tell you about the elements of mesh 1, mesh 2, mesh 3, and mesh 4. It is very important to carry out a grid independence test when carrying out a CFD simulation. For our case, the mesh ranges from 283702 elements to 830571 elements. And the time steps that were chosen ranged between 0.01 to 0.0012. Here you can see that for all the four meshes were compared against each other, and it was found that mesh 2 gave the most accurate and most effective results in the least amount of time compared to other meshes. Validation study. For our case, we did the validation study compared to the experimental findings of Fajani et al. 2010. What we found that the study shows good accordance with the experimental results or experimental data of Fajani et al. And here you can see the comparison for the profile at x by d equals to 10. I should also mention that the turbulence intensity taken in this case was 0.05 for all studies. Next, I'll discuss one of the most important aspects of our results, which is the pressure drop. Now, what is a pressure drop? Pressure drop in simple terms can be told as the pressure inlet minus the pressure outlet, or the difference between the pressure at the inlet and the outlet. Now, why is this important? The pressure drop is important because if the pressure drop increases significantly, it means more power or energy will go into that certain component. For example, in our case, the air vent. If the pressure drop increases in terms of an air vent with a high number of louver, that means a higher amount of energy will be going into providing the energy for this vent. That means the cost will increase. Another thing that can be taken into consideration is noise. As the pressure drop increases, the noise will also increase for the vent. Here you can see that the pressure drop and the flow rates are compared. For the when the pressure drop for 6 louver vent, you can see is much higher compared to that of 5 louver vent or 4 louver vent. The pressure drop increases more than 4% when the louvers increase from 5 louvers to 6 louvers. Next, you can see the pressure drop versus the blockage ratio. It reiterates what I said before. As the blockage ratio increases, the pressure drop also increases. For velocity analysis, we can see that for the maximum velocity versus blockage ratio, the velocity falls more than 4% when the louvers increase from 5 louvers to 6 louvers. That means that when the 6 louver vent, the maximum velocity drops more than 20%. This is a huge loss in velocity and power. Here you can see the comparisons between velocity streamlines for flow rate 0.027. Here for 0.041, here for 0.056, and here 0.080. You can see that the 5 louver vent allows for a more smoother airflow, and it actually provides a further distance for the airflow. Next, the velocity contours for 0.027, 0.041 meter cube per second, 0.056 meter cube per second, and 0.080 meter cube per second. What you can clearly see is that the velocity retains much more for the 5 louver vent, and the airflow also travels a much farther distance compared to both 4 louver vent and the 6 louver vent. Here I'd like to conclude my study with 3 conclusions. Firstly, the study shows good accordance with experimental data of Pachani et al. 2010 for rectangular vent. The study finds that the pressure drop increases with the increasing blockage ratio, and when compared to 5 louver vent, the pressure drop increases more than 4% for 6 louver vent. The velocity also drops significantly for 6 louver vent. The velocity decreases more than 20% for 6 louver vent, or a blockage ratio greater than 3. I'd like to conclude my presentation here. Thank you for listening thus far, and I hope I did justice to my study. Thank you all for listening.